So today I have the pleasure of sitting here with Dr. Steve Summerfelt from the Freshwater Institute, a division of the Conservation Fund, longtime partner of Bell. He's done a lot for the engineering aspects, many different types of management plans, bio plans, mass balance that we've worked with. I'm going to be asking Steve some questions about the RES industry. So Steve, I look at the work you're doing there at the Conservation Fund as groundbreaking work, and I want you to tell us a little bit about the research you're doing, the things that you're doing to ensure the success of indoor recirculating aquaculture fish farms across America.
Well, we're lucky to be working with the U.S. Department of Agriculture Ag Research Service funding for over 2 decades. And that funding is letting us pioneer new technologies to increase farm fish production and systems that practically eliminate water pollution. We really aren't free to pollute. To use very little water, so you're using less than 1/2% of the flow that would be required in a traditional system. And then to capture, thicken, and reclaim those wastes so that you can actually produce a revenue stream from the nutrients. We feel it's very important to develop this technology because the United States is resource limited. We don't have the water resources to expand aquaculture in traditional manners. And we are very protective of our water. We aren't allowed to discharge, so we have stringent discharge limits. And these technologies let farmers like you locate the farm almost anywhere, close to the market, close to the grains, close to the feed supplies, and also away from sensitive ecosystems. So it's a win-win situation. We've got production technology that can be expanded across the country with very little impact on the environment. Another feature we love that you're taking advantage is these systems are closed containment systems, so they exclude obligate fish pathogens. And with that, we don't have to use antibiotics, pesticides, vaccines, or harsh chemicals if we can keep the obligate fish pathogens out. Those are the fish pathogens that only live on fish. And as you know, that works very well. So at the Freshwater Institute, we haven't used antibiotics for well over a decade, and we don't plan to ever use antibiotics again. It's a matter of strict biosecurity. So our research has developed a technology to keep clean water that can raise the fish as fast as it can possibly grow with an excellent feed conversion, which means it takes less feed to produce the same amount of fish. That makes this system more cost effective, and especially when we have better survivals, better fish welfare, because we have excellent water quality without disease. It's certainly without the obligate pathogens.
Well, Steve, I look at one of the unique aspects that you brought to Bell that was a challenge for us is this concept that I think you do very well, and that's mass balance. Can you explain a little bit about what mass balance is and why it's so critical to our industry, and when you build a new farm to really consider that?
So the Freshwater Institute, we have 3 PhD level engineers. I direct our aquaculture research as a chemical engineer, and the fundamentals of what we're doing is trying to make clean water. We have to have the water clean enough to get excellent growth and performance and health of the fish and their welfare. And to achieve that, we need treatment processes that remove the waste, primarily ammonia and carbon dioxide and solids. And to do that, we do a mass balance where we track how much of the waste is produced and then how much is it removed, so that we can have water that's pretty much drinking water quality for the fish. And it maintains a better environment, and it's good for the farmer, it's good for the consumer, it gives you a very healthy product.
And the other thing I think it's unique in your approach is that, you know, in the terrestrial animals, we see that we do a lot with the byproducts, no matter what that may be. But in aquaculture, we don't see that as much. And you're doing some research along those lines. And tell us a little bit about your research you're doing along those lines.
So fish are raised in water, and all terrestrial animals are not. So it's a challenge to remove the waste from the water, but the waste is a valuable byproduct. We're actually going to be limiting on phosphorus because it's a mineral within the next 50 to 100 years. It's a key ingredient for farming. So our challenge has been to cost effectively remove and concentrate those biosolids so that they can then be reclaimed. A technique you're using very well. Once you've thickened them, you're going to try to incorporate them into a compost, a vermicompost, which is high value. So it's all about developing cost-effective technologies that work at large scale. This is farming, this is agribusiness. We're not going to reduce our $10–12 billion seafood trade deficit with little tiny operations. The cost-effective operations are the ones that compete on the world market. that compete with the imports that are coming into the United States. And a key factor of that is we remove the solids, and now we can create a byproduct out of them that's actually valuable, that you can go and create a revenue stream from it. That's what I applaud with Bell. You've done that very well.
That's perfect. One of the other things that I truly believe, and we've talked about, is, you know, the coming protein deficit by 2050, where we need an additional 200 million tons of protein. And I've always believed that we have part of the solution for that, and I want to hear your thoughts on that.
Well, the United States are the best farmers in the world. Here we're sitting in Indiana, and really the heart of our agriculture. We produce 40 million tons of livestock annually. That's hogs, cattle, and poultry. Yet in aquaculture, we're less than 1% of that. Why, when we're the best farmers in the world, we don't have the right technology? How do we overcome this so that we're not competing with the rest of the world that's becoming more affluent and able to purchase these scarce, high-quality seafood that we took for granted for decades? In fact, much of the New England coast and mid-Atlantic was developed on seafood with fisheries. And our fisheries are overfished. We don't have that anymore. For us to feed our population with healthy, safe, local food, we've got to produce it ourselves. So this is a huge challenge for the next 50 years, because not only do we have an increasing population growth, we have decreasing resources. So there's not the water supplies to go after to do aquaculture in the traditional manner. There's not the land to do it in the traditional manner. A pond system takes 100 acres for every acre we use for land-based closed containment and recirculating systems like yours. So not only are we protecting our water resources, but we're protecting our valuable land resources. We need as many acres to plant in crops as we can without taking it away for fish farming. So if we're comparing against pond culture, your facility at Bell Aquaculture is probably 1/100th of the size it would be for the same production in ponds. The intensification here, the control of the environment, is allowing for approximately a 100-fold increase in production in the same unit area. So these intensive systems are really critical to the success and growth of agriculture in the U.S. to provide this healthy seafood.
Well, Steve, I just want to thank you that you're a great partner to the RAS industry and also to Bell, and we continue to look forward for your expertise and support of the industry.
It's great to work with you, Norman. Thank you.
Thank you.